In part 2 of section 3, we're going to take a deeper look at the concept of domain and range, but this time we won't be doing it from an equation perspective like we did in section 1. This time we'll be doing so from a graphical perspective. So we have to be familiar with the fact that there are two types of maps that we're going to encounter. We are going to encounter infinite maps, and we're also going to encounter finite maps. When we have an infinite map, it's going to be important that we use interval notation, because just the fact that we have an infinite number of something makes it impossible for us to just make a list. When we have a finite map, then we don't need to use interval notation. Instead, we would just be opening up our curly brackets, and then we just make a list of all of the values inside. So looking at all of these examples, example 3.2, it says determine if each graph represents a function of x, then if it is, state the domain and range of that function. So taking a look at part A, so for part A, we can see that if we were to apply the vertical line test, right there, this is not going to qualify as a function. So this is not a function. So let's move on. On part B, if I was to apply the vertical line test to this, I would have no problem, and this would qualify as a function. So up here at the top, I'm going to write is a function, and then I'm going to proceed. It says, then you want to find the domain and the range of the function. So I'm going to start on the far left, and if I start over here on the far left, I have a point which has an x value of -2. So I want you to watch closely. As I start at this point and start going around my curve, I'm going to stop up here at the top at this point. The x value at that point would be 0. So I'm going to come down here to the horizontal. I'm going to mark 0 here in green. And I'm also going to mark -2 because that was the starting x value that I had. Now in the process of going from the point at -2, 0, the one that's sitting here on the x-axis, to getting to the point here at the top on the y-axis, I had to get there using a continuous line. I couldn't pick up my pencil or my pen here. So that means that all of those ordered pair have to represent the x values in between -2 and 0. So what I'm doing here is trying to keep track of all the different x values that this particular map is using. And I'm having to do so graphically. So let me go back to where I was at on the y-axis, and let me continue to go around this curve until I get all the way down here toward the end where I have an open circle. So here with that open circle, that means that I'm not actually supposed to be including the value of 2. But by the same logic I used for the first half of this example, since I had to draw a nice continuous curve from the top all the way down to the horizontal axis again, that means that I covered every single x value up to that point. So the domain is always going to describe the x values that are being used. So here I would say that the domain of f is the interval from -2 to +2. Now I'm going to include -2 because there's a solid point there, but I won't include +2 because it's an open point there at the end. And the range can be done in the same way. So let me clear the map, get all these things off of here, and let's start again. So if I start back on the point at -2, 0, that has a y value of 0. And then as I start to go up the curve I will eventually get to this point that has a y value of 2. And every y value in between 0 and 2 has to be used in order for me to make this quarter circle that I've created so far. And then if I continue to go around, I will eventually get down here to where I'm at a y value of 0 again. Now, that does not say that I'm supposed to be including 0, but I've already included 0 because of what's happening over here on the left-hand side. So as I go around to finish the circle, or the half circle here, I'm not introducing any new y values. Every y value has already been accounted for, going from 0 all the way up to positive 2. So for the range, I will state that the range of this function, range of f, will be from 0 to positive 2. And this is what has to be done when we're looking at a infinite map. Now certainly the more experience you have with this, the less you'll have to rely on drawing on top of the curve. You'll start to be able to visualize what the domain and the range are supposed to be. But at first, this becomes a good exercise in understanding what all the different values are supposed to look like. So for part C, I want to do the same thing. Now my graphing software has some limitations, so I need to add a few things in here. Number one, there's supposed to be a connection here to that point, and this is supposed to be continuing off the viewable window that we have. So it's going to continue there. And I want to take the same approach I did with part B. I'm going to start at the point here, negative 1, 2. Oh, and by the way, this is a function. If you were to apply the vertical line test, this does qualify as a function. And if I start at the point negative 1, 2, and I want to analyze x values, then I know that there is an x value at negative 1. And then I'm going to start going along this path, and then I'm going to pause once I get to the y-axis. And at the y-axis, I know that I have an x value of 0. So everything in between negative 1 and 0 has been used so far. But as I continue to go along this curve, I'm going to continue to go further and further to the right, which means that I'm going to continue to use more and more x values over here in the positive direction. And since I'm not going to be stopping, I'm going to allow this graph to continue on moving to the right and up. That means that my domain is not going to stop either. The domain is going to continue to be accounted for moving to the right. So that means that it's unbounded on the right-hand side. And we saw some examples of these types of intervals back in section 1. So I would say that the domain for this function starts at negative 1, but then ends up being unbounded in the positive direction. So we would write it as hard bracket negative 1 to infinity. So let's try this again with the range, looking at the y value. So let me erase what I have here, and let's try to start over. So I need to make sure I put that arrow back. This connects, and let me get my starting point again, negative 1, 2. So at that starting point, I know that I have a y value of 2. And then as I start to go along the curve, I'm going to get up here to the y-axis, which has a y value in between 3 and 4. So let me mark this point here, and let me also indicate all the other y values in between 2 and what appears to be about 3.5. And then as I continue along this path, I'm going to be continuing to go up, which means I'm going to be continuing to have larger and larger y values. And just like with the domain, this isn't going to stop. The arrow indicates on my curve that I'm supposed to continue to go up and to the right, which means that on the y-axis, I'm going to continue to go up, and I'm going to do so forever. So the way that we indicate that is very similar to what we did with the domain. So we would say the range of f is going to be from 2 to positive infinity. So there's your domain and range. Let's take a look at part D. And for part D, I'm going to start at the point -3, 2. By the way, this is a function. Now I'll go ahead and tell you this as well. The one place that students sometimes struggle with is right here. This vertical line right there, because all these other vertical lines that I can draw are only going to cross once, and those are fairly obvious. But it's this one right here that students sometimes struggle with. Now remember, if I cross an open hole, that means I haven't really crossed anything at all. And that means I only have one place that I really crossed. So if that one vertical line is holding you back from saying that it's a function, go ahead and let go of that, because you are actually only crossing one time. You're not crossing more than once. So this does get to qualify as being a function. All right, back to the domain conversation. I need to mark -3, and I'll start going down the curve, which also takes me to the right, and I'll stop at this point momentarily and recognize that the x value there is -1. So every value between -3 and -1 has been covered. Then I'll continue my path along the curve until I get up to this point, which has a x value of +1. So everything from -1 to +1 has also been covered. And that would be my analysis for that first piece. But the function itself is both pieces put together. This is an example of a piecewise defined function. So now if I start to look at the second piece, I'm going to start on this open circle here. And let me switch back to red. Open circle here, which means I would technically have to put an open circle at 1, but if I already have a closed circle there, then it's closed. You know, an open and a closed circle just makes a closed circle a closed point. So I'm going to include that. And then as I continue to go to the right, I'm also going down, but I'm not looking at the y values. I need to be looking at the x values. If I stop right here, the x value at that point is 3. So everything from 1 to 3 gets used. And then if I continue to go along the curve, there is an arrow there that's implied that's going to be taking me further and further to the right. So this is also an example that has an unbounded behavior with it. So our domain, because of the way that the two pieces end up overlapping with their x value, the hole and the solid point, the domain can be written as just one interval starting at -3 and going all the way to positive infinity. Let's do the same thing for the range. Let's analyze the y values. Starting at the point -3, 2, I have a y value located at +2. Then I'll go down the curve until I get to this point, which has a y value of -2. So everything in between 2 and -2 has been covered. And then as I go back up this first piece, I'm going to end up right here back at a y value of 2. So everything that I already have marked on the y-axis is there. So I don't need to mark it again. I don't have to duplicate that. But let me go now to the second piece, where I start with a y value of -1. So I am, just for illustration purposes, I'm going to put an open circle here at -1, and then as I start to go along the second piece of this curve, let me stop momentarily here. I recognize that there's a y value of -3. So from -1 to -3, which is going to introduce some new things for us. I already had everything up to -2, but now I continue on to -3. And then I'm going to allow myself to go on the rest of the curve, which is going to continue to go down forever. So this is going to go from -3 down to negative infinity. So starting at positive 2, I'm going to cover every single conceivable number until I go down toward negative infinity. So when you're writing a range, you always want to write it from least to greatest. So that would be from bottom to top. So for the range, we're going to start with saying negative infinity, and then we're going to go all the way to positive 2 with a closed bracket. And that'll get us the range for part D. All right, last picture I want to analyze is part E. Now this is an example of a finite map. And if you start drawing vertical lines, I don't care where you draw a vertical line, there is no way that your vertical line is going to cross more than one point. Now sometimes it doesn't cross any point, but that's not a problem. Vertical line test says it can't cross more than one point. So every vertical line will be perfectly okay, which means we are going to have a function. So this one is a function as well. Since it is a function, we're going to write the domain and the range down, and the domain, since this is finite, can be listed. We don't need an infinite number of values, so we don't need an interval. So I'm just going to write down -2, 0, 1, and positive 3. So those would be all the different x values that are used in this graph, and the range will be done similarly. -3, -1, positive 1, and positive 2 would be all the different y values that are being used. And that's how we can find domain and range when looking at a graph.